Hi, I'm Mike Jeffries. I'm doing Disk Design 101 today with Nate Franklin. I brought Nate in to give me a bunch of parameters on a disk design, and then I'm going to walk through how I would design my own disk to meet those parameters. So we're going to be starting this with a basic template I use. This is for the Repeat Robotics hub motors, the ant weight size ones, and I've already gone through and made this basic ring. I can walk through a couple of the features I did for that to begin with. So with those, I started with a ring that had the outer diameter I wanted as kind of like my minimum dimension for anything going around the hub motor. And the ID that I found when I sent it off to SendCutSend for laser cutting gave me a pretty nice fit consistently, even if I put a little bit of paint on it just to make it look nicer. Then I went through and added the M4 clearance holes to match the motor pattern, cut out some small notches to match up with the notches that are integrated into the hub motor design, added cutouts for the M4 holes on one side. With laser cutting, often it's the case doing this continuous cut is going to be a lot more efficient than trying to do multiple pierces in a part, and you don't really lose much strength. Repeated that pattern on the other side, and then just went through and filleted it to make sure that it was nice smooth curves, no sharp edges on the inside because stress risers are bad. So with that, Nate, do you want to start setting up what parameters you want for this disk?
Yeah, so um thickness is 5 millimeters, weight is 55 grams, and the um diameter is gonna be um 78 millimeters in diameter. The effective diameter is 78 millimeters.
All right, so for that, I'm going to start with going back to this base part. And the nice thing is with how I did this drawing, you can see 1.265 and 2 for the dimensions. I can go and change this 119, that's the thinnest air 500 that SendCutSend sells. Switch that to 5 millimeter. We've now got our extrude at those dimensions. And everything else auto updates just with how this is set up, which makes it pretty painless to use. So next up we have a known target outer diameter. And I'm going to set this up as construction geometry. What this means in SolidWorks is this isn't something that would actually be extrudable. This is creating reference dimensions for you. So this is 78 millimeters.
Yeah.
So there is our 78 millimeter diameter. Next question I've got for you is how much tooth stick out do you want?
Like a number?
Do you want it to stick out like 3 millimeters, 5 millimeters, quarter inch, something like that?
Um yeah, 5 millimeters sounds good. I don't have my I don't know if I have my calipers on me, so I can't measure what my current tooth is, but I'd say about 5 millimeters.
Yeah, that should be pretty good. I mean, this thing's going to be spinning at tens of thousands, at least 10,000 RPM full throttle, and you're going to be hitting well before you'd get nearly 2/10 of an inch of depth. So I think that'll work just fine for this. So I've got now our two reference circles set up. We got our outer diameter, and then this is a secondary diameter that's limiting how far I will go with weight relief.
For the outer diameter, are you able to do it in such a way that, let's say, okay, 78 millimeters is a bit too big, so I'd have to redesign stuff. Would you be able, like, after you design it, to say go down to 77 millimeters and it won't like mess up the center of gravity?
So it'll need some tweaking to the center of gravity, but I can keep like this spacing just fine. So I've got it set
Oh,
up right
okay.
now, so 77 millimeters just shrinks that slightly. Realistically, changing it by 1 or 2 millimeters once we've got this pretty close to balanced isn't going to do a whole lot. So that shouldn't be a big issue. So next question, do you want a single direction tooth or a bidirectional tooth?
Um, let's go single.
All right, so we're going to
I think
go
that'll be
with,
fun.
yeah, a little more fun shape to it. So for that kind of thing, I think I'm going to start with a small, I'm going to go this direction just for the sake of why not. And then I want to do a nice center line. That's going to be kind of our reference to vertical here. Go 10-degree rake angle holds up pretty nicely on a lot of AR weapons, so that should be plenty good there. Then a little bit of support at the back of the tooth, just so we've got some margin. And this is then going to be 3/16 of an inch, so that should be more than enough tooth to work with. Now I'm going to go in, make the main curve of the front side of the tooth. So setting that to tangent, setting this to tangent as well. You don't have to, but that creates a nice smooth transition all the way into the main body of the disc. Then I'm going to go with that as a baseline spot for the tooth to sit. Again, making it tangent. You can get around this by adding fillets and things like that, but this will get things nice and clean. I'm going to also set it horizontal relation to that point, so it's attaching at 90 degrees from this point, reference point for the tooth. So that's going to be our main tooth profile. And now to do the counterweight of it, well, before I forget, I'm going to throw this in just so it's a complete shape. Now the counterweight is going to be using this secondary line, and I'm going to start with generally some kind of ballpark references here, just because I don't know exactly how it's going to balance out until I start rendering things a bit more. So we're going to put this at 30 degrees. And these are all arbitrary. This is me kind of just picking a starting point and 75. Now, since this is a single direction spinner, it's going to be rotating clockwise from the current angle. You could get away with just having this transition smoothly into the disc. I think from a styling standpoint, I like doing something a little like this, where you've got this coming in tangent to there, coming in tangent to here. Again, it's not really doing anything, but I think it looks nice. And then we're going to go and put the opposite on this end, bring those to tangent. And here you'll actually want to just set some sort of dimension. So this is setting the radius of this curve. The smaller you make that, the tighter that's going to be. So 1/4 inch there is too tight because it comes back in. That should work. And then what we're going to do after the extrude is fillet this so we get a nice smooth transition back into the main piece of it. Now I can come in and add another curved line to close that off, and we've got our first pass at a tooth profile. So that will all be extruded. What I like to do for 2D cut discs, just to avoid having to change stuff if I decide, oh, I want to go 4 millimeters or 6 millimeters in the future, I use up to surface extrudes. That gives me identical dimensions on every feature, which is pretty helpful. So we've got our first pass, but before I check the CG, I'm also going to add the fillet here, because that will impact the final balance point. And I already had the face selected, so it's freaking out a little. Let's go with a 6 millimeter fillet. That's just setting the radius of it. So now it's a relatively smooth shape. You've got kind of a pseudo secondary tooth if someone does actually get close, not that they should. And now we can check our weights. So mass properties, first pass we are at 75 grams, 75.5 grams. And you can see that the center of mass is off a bit. One thing I'm going to do just to make it a little easier for anyone watching to see it is I'm going to add a sketch just with a nice little dot at the center point here. So now when we go and look at the center of gravity, In mass properties, you can see the offset here. So what this is telling me is there's too much weight in the counterweight, and we want to either add weight to the tooth side or remove weight from the counterweight side. Given we're targeting 55 grams for the weight of the disc, we're going to be removing weight from the counterweight side first and seeing how close we can get. So for this, I go back into the sketch, and we know that these were way too much, so I'm going to try 55 degrees and 20 degrees. Exit the sketch, and it's already back to something you can check against. We're now at 70 grams, and it's drifted closer. So we're making progress, we're not there yet. This is a little bit of an iterative process, but if you want to be actively in control of how your dimensions work out, this is a very clean way to do it. Now we've got 5 degree and 35 degree. This should be getting a lot closer. We may need to take a little weight out somewhere, but we're going to be at least in the ballpark to balanced. So we've now got a center of mass that is off by 9 thou and 3 thou, which is pretty good. Mass is about 10 grams above what we want though, so while this is close, we're going to have to go back in and tweak some of these tooth dimensions to get it in line with what we're after. So one of the steps I'm going to do is actually go in and reduce that angle. So now I'm going to make this angle something I can control because we know we need to take weight out of that side. So let's set that to 30 degrees. I've got a little thinner tooth, but we've still got a decent amount of meat to it, and if this thing's made out of lasered AR500, it's going to be plenty robust. We also need to take some weight out of here, but given how much weight we're going to take out, I'm actually going to bump this up to a 6mm gap, and as you can see, changed pretty easily and reduced the amount of mass hanging out over there. So we're now at another good point to check. We are at 59.6 grams. Center of mass is drifted again off to the heavy side, to the counterweight side, and we can go in and bring this down to 30. Bring that to 2.5. And we are getting much, much closer to dialed in. So 58.46 grams, pretty close. Still need to shift some weight off of the counterweight side, and specifically the right side of the counterweight side, and put it in the tooth side. So I'm going to bring this down to 20, and that might get us about where we want to be besides taking another gram or two out of this thing. So basically 57 grams, slightly heavy to the tooth side. So as a little bit of minor weight reduction, I'm going to take a 1/16 of an inch fillet here. Let's bring that up to 1/8 inch. So that'll be pretty much meaningless when it comes to strength reduction, but it does take just a little tiny bit of weight out from a surface that is as far from the center of rotation as possible, so it's going to have the biggest possible impact. All right, we need to take another hair off of the disc or the tooth side, and then another 2 grams total out. So I'm going to go through and I'm going to make this 2 degrees, 17.5 degrees, and let's make you 25. Or no, 35. Wrong direction. Now we're at 56 grams, and we've got the mass just a little bit out to the tooth side. So need to pull 1 more gram out of this thing, and mostly even between the two. So for that, what I'm going to do is actually go in and tweak this. And I'm going to continue this tooth profile down. So that will now be collinear. And I'm going to give that an extra 3mm. Now I can go back in, redraw this curve with the new points. And doing this full radius isn't necessary, but it's just a little bit of how I like to do it. So now we've taken some mass out of that end of the tooth. We are at 55.7 grams. And again, just a hair out that way. So I think I want to take weight off of, again, the bottom right corner. Let's do 15 degrees. So 55.3 grams with the center of mass just a hair out to the tooth side. It's not even really necessary at this point because we're well within laser tolerances, but I'm going to up this to 1/4 inch. So you've still got a little bit of that top of the tooth that follows the overall diameter, and then a nice meaty back to it that will help with load distribution on a hit. 55.2 grams. We're basically dead center vertically, and then just a hair off from the tooth side to the counterweight side. Realistically, this is probably usable because you want a little bit of extra weight on the tooth side typically, as the tooth is going to wear out faster than the counterweight. But just to see how close we can get this, I'm going to take... that's not the side I want. Never mind. I'm going to go in and we're going to up this slightly to 4mm. And that will probably have us right where we want to be. Yeah, we're still, 0.2 grams over, so we can shave that last little bit. So what just happened is going to 40 degrees there would force the sketch into a position where it couldn't solve it. So let's see if 37.5 is, nope. All right, 35 is about our maximum. And in that case, what we're going to do is slightly increase this radius. Or no, slightly decrease. So 325. And then increase this to 17.5. That added a little bit of weight to it, but it pulled the center of mass in closer. So we are 2 thousandths to the right and 7 thousandths vertically. That's basically perfect as far as laser cutters are going to go. And if we want to shave down those last few thousand or fractions of a gram, the easy way to do it is to go in and play with something like this, make it a, that'll break it too. So we'll leave that at 10. As you go through and build more of these pieces into it, you run into stuff like that where it's already pretty well set. Let's go 5mm here. It's a little tighter radius, and then I'm going to go edit this fillet and actually make it just a hair tighter as well. So that'll take a little bit of weight out of both sides. So 55.25 grams and near perfect.
And that's as perfect as you can get.
You can go through and fine tune it even more, but at this point we're changing the dimensions within the tolerance range of a laser cutter. And
Right.
realistically, the weight you're seeing here where it's at 55.26 grams, that is for a theoretically perfect thickness plate. You're never going to get a perfect thickness plate. It's going to either be a little thin or a little thick, and you're going to, if it ends up on the thick side, want to go in and lightly sand the sides of the disc to get it down if you need to, or just work with a slightly thicker material.
Right, but as far as like a balancing perspective, that's as good as it'll get.
Yeah, so there's some decisions you can make with this. So like I generally consider if the dimensions are within 2 thou of target or within 5 thousandths of the target, it's effectively not going to have any difference from a balance perspective. You're at the point where the tolerance of the machine doing the fabrication is going to make it more different than your design tweaks. With this one where it's 7 thou past towards the tooth side, that is an intentional decision to push a little bit of the mass out to this tooth, so as it hits things and that tooth wears out, it's going to wear through being perfectly balanced over the life of the disc. And that little bit of vibration is going to be basically unnoticeable when you're driving.
Oh, okay, that sounds good. And then for the pattern in relation to the tooth for the hub motor, it has to be like aligned with the tooth. So that's fine, right? Because I assumed that it was like with the curvature of the tooth, but as long as it's
So
like
you're talking about the mounting holes here, correct?
yeah, the mounting holes.
So it in a sense it doesn't matter where those are relative to the tooth because it's all going to be spinning concentrically. There are a few things where how you place those cutouts can matter.
Right.
So if you had a narrower profile here, like I would not want to have this rotated such that this feature lined up with this cutout and then
Right.
over here lined up with this cutout because then you've got your highest stress points in your disk lined up with areas where you've removed as much material as your design has.
Right.
So by
And then I
having this sort of centered between the cutout, you've got a lot of material here. Here is going to be a bit lower stress, and then this whole area is really chunky and will be able to hold up to a lot. So this is going to see on a hit more compression loading in this area. This will see more tensile loading, and that should be a pretty good area from a tension standpoint. And with the compression loading, that's going to be more what's inclined to bend a disc on a hit. So having that with this large area here is going to be helpful.
sounds good. And then I guess so that like it would also be an issue if the pattern was rotated like 90 degrees.
Yeah, so if you rotated this 90 degrees, the reason I tend to not do that is you've then got it here where on a hit, you've got a very thin cross section right near a load path. And to some degree, you can't really get away from it. Like with this one, it's a reasonably chunky disk to begin with, and it's not going to have huge loads. So you could do that just fine here. You could go in and rotate this however you wanted. You could even do something like, let's see, that and have four of them, and it wouldn't really matter. I didn't bother bringing the holes here with how I did the circular pattern,
Right.
but you could have that and be able to index this thing 90 degrees, but it wouldn't really matter. The big thing is you want to avoid having a path from the bolt hole to the edge of the piece not being located near a high stress point. So that's going to be right in this part of the tooth. That's your highest stress point. So you want that at least with some physical separation from your bolt holes.
Right. That's a pretty comprehensive guide. I don't really have any more questions. I'm very impressed with it.
All right, do we want to do a really silly design just to show how far you can go from a like I'm doing something completely weird. Also, I'm going to save this out.
Yeah. What do you have in mind when you say a fun design? Like the fish bone one you did for that ant weight?
So something like that where you're basic it's like a completely unusual shape that's not really conducive to being a disc.
Right.
So like over the times I've done some pretty wild stuff. I think the craziest was I did a design that looked like a wizard.
A wizard?
So for this, you wanted me to show how I did that and actually got it balanced.
Yeah, sure.
All right, so I'm not going to worry about hitting an exact weight. I'm just going to show how to balance it here. So for our wizard disc, going to go a little wider for the tooth area, just because it's a complex enough design, you need some room to work. So I'm going to start with drawing out the base of the wizard's hat. And I'm still using the same basic rules I was using for the other setup for this, where I've got a diameter that I keep all of the other features within, and a diameter that I use for the actual tooth. And I should probably set those just to something. So we'll call this 6-inch, and we'll call this.
How are you setting the 6-inch as the reference one?
So I'm using the Smart Dimension feature in here, and then selecting the construction circle.
Yeah.
So I'll just do that again real quick. So if I go through Smart Dimension, and then I can highlight this circle, and it'll, prior to me setting that dimension, just tell me what it was, and then I can set it to what I want. So
Oh, okay. I
that
thought there
grows it
was
out.
something more that you'd have to do. Because, like you said, so it doesn't extrude.
Yeah, so it's basically like template lines that you can use.
Oh, okay.
So now we go in and we got our initial kind of wizard hatty feature. And I'm going to actually drag this down just a little bit because I think that looks better. And now we come down, and this is where it gets particularly fun. So we've got because I mean, really, what good wizard doesn't have a big
Beard?
fuzzy beard?
I don't know. Can't think of any without beards.
And this, I'm being pretty arbitrary with it because none of these dimensions really matter outside of it just trying to be, eventually balanceable. And just for the sake of making this a little cleaner to work with, tried to go with a tangent on me. So sometimes SolidWorks will do that where it'll create a tangent line for you. Uh, got there and there. What I'm going to do is grab the Trim Entities tool. I could just make it extrude it if I wanted to, but that cleans up that line nicely. And now we go in, draw that circle. And I'm actually going to break these apart just for the sake of making it a little easier to see the two distinct parts of this.
Right.
So now we've got our basic wizard shape to start with. Again, I'm going to go extrude up to the surface. And let's see how close or far we are. Pretty far. So this is a 160 gram disc, so pretty hefty. you'd probably go with 3mm instead of 5 for this, just for the sake of making it more usable. But what I need to do is I need to take some mass out of the hat side or add it down to the counterweight side. So I'm going to go in, and this is going to be a lot more aggressive on some of these features. So a little steeper hat. Let's see where that gets us. That's already moved it in quite a bit, and I don't want to take that too much thinner, so I'm going to go through and start adding some fillets just for a bit of structural integrity on that side. Let's do 1/8 inch fillets. So at this point, I'm going to try to not really tweak the hat area much, unless I decide to add a cutout to increase the weight reduction on that side. But I think, given it's a wizard, I can make the beard a little more intense.
Well, the two brims on the hat, those being like asymmetrical, will that have any effect on anything, or are they symmetrical? They don't look like it.
They're entirely arbitrary at the moment. All they're going to do is function as counterweights, kind of like the other.
Oh, okay.
So it's just more weight on this side. So I can actually go in and like trim those up, and that'll actually take some weight off of that side to make it work a little better. But let's give Wizard bigger, bushier beard. Let's see how this looks. Pretty wizardy to me. And now we're getting much closer. So we are about a 1/16 of an inch off in two directions. So we need to take some weight off from basically up in this corner. So I'm going to grab that hat, the hat like that, and bring this in that way. And what I can also do is, because these don't need to actually go all the way out, I can bring that in so it matches up a little more now that I've moved the base of the hat this way. All the fillets stayed because it's flexible enough. And now we are getting much closer. Close enough, I'm going to add the center mark sketch. So as you can see, still need to go a bit that way and at 145 grams, but that doesn't really matter. I'm going to get this more in line by moving weight this way. So the bottom of the beard was lined up with the center line, so I had to delete that reference point just to get it to move the way I wanted it to. And we are now just shifted off to the left, but we are perfectly aligned vertically. So I just need to pull weight from this side to the right, and ideally an equal amount in both directions. So let's go a little bit there and a little bit there and see where that gets us. 5 thou and 2 thou. So we are now slightly heavy to this side. Just because I can, I'm going to go in, pull that there, and that should get us pretty close to perfect. So 1 thou in X, dead on in Z. And there we have a single tooth wizard hat, or single tooth wizard disc in under 10 minutes. All just using the same basic structure to create it, where you've got couple of reference circles, and then building around a common base that you know works for your weapon hub.
If weight wasn't like an issue, like assume like or hypothetically if it wasn't an issue, obviously it's just a hypothetical. Would you want to add more material to the top of the wizard hat where there's the tooth? Like
Yeah,
or
absolutely.
extra
So if I
material,
were
yeah.
going through to try and optimize this, what I would likely do is put a triangular cutout in the hat itself, and then put a bit of extra meat in this area on the tooth, just so there's a little more material out there to work with. But optimizing a design like this, especially with this wacky of a shape, can take a long time. What I would do with this disc is I'd probably take it down to 3 millimeters thick. And now you've got a effective, what was it, 6-inch diameter disc that's 90 grams. If I were feeling so inclined, this is within a couple grams of what I would need to actually be able to run on an ant weight I've got right now. This would be so thoroughly unhinged that I'm not going to, but it would technically work. Alright, so with that, we've covered a pretty traditional design and a completely wacky shape that shouldn't be balanced, that a lot of people would go through and draw their shape and then just put a hole at the center of mass. This is going through and actually intentionally setting your diameter, setting your center of mass, and building the shape around it. So I think with that, I'm going to call this video complete. If you have any questions, feel free to ask them in the comments. I'm happy to give any other tips and insight. And have a great day.